students, in this video I am going to discuss a very interesting question from the topic related to ellipse and area under the curve. The question is, let A 1 by 2 comma 0, B 3 by 2 comma 0 and C 5 by 2 comma 0 be the given points and P be a point satisfying the condition maximum PA plus PB comma PB plus PC is less than 2. If the area of the region P is under root 3 pi by 3 minus root 3 by m, what we need to find? We need to find the value of m. Now I am going to give approach how to solve this problem. This problem is mainly based on concept of ellipse. Here what we find, a point P is moving along the circumference of ellipse. What we observe, if P of F1 is equal to P plus P of F2 is equal to 2a, what does it mean? This means the point P lies on circumference of ellipse, and what about this 2a? This must be greater than F1, F2. Then this point P lies on ellipse. But what about P F1 plus P F2 is less than 2a? If this is the situation, this means our required region is, this is our required region. So this is the key step to solve this problem. Here F1 and F2 represent the focus of ellipse. Now I am going to apply this concept here to solve this problem. Now let us understand the region 1 by 1. What is given here? It is given here coordinate of point A is 1 by 2 comma 0 and coordinate of point B is 3 by 2 comma 0 and C is 5 by 2 comma 0 and maximum PA plus PB comma PB plus PC is less than 2. Now what will happen when PA plus PB is less than 2? This represents the interior part of ellipse which foci are A and B. What is coordinate of A? This is 1 by 2 comma 0 and this B as 3 by 2 comma 0. So this represents the interior part of this ellipse. Now what about center of this ellipse? Center is C1 is 1 by 2 plus 3 by 2 whole divided by 2 plus 0 by 2. So this C1 is 1 comma 0. So center is 1 comma 0 and let us compare PA plus PB is equal to 2a. Just equating this to 2. So what is 2a? We know that PA plus PF1 plus PF2 is equal to 2a. So 2a is equal to 2. So a is equal to 1 here. And what about this length? This length is equal to AE. So AE is equal to 1 by 2 only. So A is equal to 1. So what does it mean? E is equal to 1 by 2. So E is equal to 1 by 2. What does it mean? B square is equal to A square 1 minus E square. So B square is how much? This is A square is 1 into 1 minus 1 by 4. So this is equal to 3 by 4. So what is equation of a required ellipse? Equation of required ellipse is x square by a square is 1 plus y square x, this is x minus 1 whole square because center is 1 comma 0 whole divided by 1 square plus y square divided by 3 by 4 is equal to 1. Now in this case PA plus PB is less than 2 is given. So this represents interior part of this ellipse, interior part of ellipse as shown in the figure. So this part, inside part, interior part of the ellipse as shown in figure. Now PB plus PC also given less than 2. Let us apply that concept also. Now PA plus PB less than 2 represent interior part of ellipse x minus 1 whole square by 1 plus y square whole divided by 3 by 4 plus is equal to 1. Now what about PB plus PC less than 2 represent. This again represent interior part of ellipse whose center, that center C2 is 3 by 2 plus 5 by 2 whole divided by 2 plus 0 whole divided by 2. Center is given by 2 comma 0. So this C2 2 comma 0 must be center. And what about B and C? B and C are the foci of this second ellipse and center is 2. So what is again this length? This length is again equal to AE. So again eccentricity AE is equal to 1 by 2, and A again simply equating PB plus PC is equal to 2A. So again A here is 1 because so E is equal to 1 by 2. So what about B? B square is equal to A square 1 minus E square. So this is equal to 3 by 4. So what about equation of this second ellipse? So equation of second ellipse is x minus 2 whole square divided by 1 plus y square whole divided by 3 by 4 is equal to 1. And PB plus PC less than 2 represent interior part of this ellipse. Interior part of this ellipse. Now, what is given here? Maximum of PA plus PB and PB plus PC less than 2. What does it mean? This represent our this required region. Maximum of this required region. Now we need to find area of this shaded region. So our required area is nothing but 4 times area of C2BQ. C2BQ simply represent this region. If we calculate the area of this region, simply multiply this region by 4, we calculate the overall area. Now what is curve C2P, this curve? From here we have calculated this equation of this curve, which x minus 1 whole square plus y square by 3 by 4 is equal to 1. So from here simply apply the concept of area under the curve y dx. So what is y here? Y is equal to under root 3 by 2 1 minus x minus 1 whole square. Now putting the value here, area is 4 times root 3 by 2 under root 1 minus x square dx. Now to solve this integration, simply put x minus 1 as t. Now if x minus 1 is t, so required area is this, cancel out 2 root 3, limit is from 1 by 2 to 1 under root 1 minus t square dt, and putting t as sine theta. If you put t as sine theta, what is a? 2 root 3. Theta is from pi by 6 to pi by 2. This is cos theta. Dt is cos theta d theta. So this is cos square theta d theta, and 2 cos square theta we know 1 plus cos 2 theta. So the required area is a root 3, 2 cos square theta simply, right? Limit is from pi by 6 to pi by 2, 1 plus cos 2 theta d theta. So if we calculate this further, what we find, this is root 3 theta sine 2 theta whole divided by 2, limit is from pi by 6 to pi by 2. So finally, putting the values, what we find that upper limit minus lower limit, so pi by 2 minus pi by 6, and this is sine pi, 2 theta is pi minus sine pi by 3 by 2. So this is root 3 times pi by 3 minus root 3 by 4. So what is the value of m? If you compare this, what we find, m is equal to 4. So answer of this problem is 4. So hope you understand how to approach these type of problems. These type of problems are very important for JEE advanced point of view. Thank you and see you in next video.